Cosine and tangent also have inverse functions if we restrict their domains. Let's take a look at the inverse cosine function first. I have a graph here of the cosine of x, right? It turns out that if we restrict our domain for cosine between 0, edit, hang on, home, I want to undo, there's a way to undo, hold on, I'm going to pause it. Okay, so if we look at the cosine function and we, go between 0 and pi on it, we can see that that creates a one-to-one function, right? Just the part between 0 and pi. So that's where we're going to define our inverse cosine. So we say y is cosine, or inverse cosine, where the x values again, right? Remember, the x values for inverse cosine are the y values for cosine. So between -1 and 1. And the range, or the y values, again for inverse cosine, right? Y is going to be between 0 and pi, including both of those values. Okay? All right, because it's 1-to-1 there. Yeah. All right. Now for inverse tangent, we are going to restrict our domain. Again, it's not 1-to-1 right now, but we can, if we restrict our domain to just one of these, repeated shapes, yeah, then we can get something that is 1-to-1. So I'm going to erase those two, and it turns out that inverse tangent function is going to be defined where tangent is where the angles are between -pi/2 and pi/2. So we'll say y, but not equaling, because there is no tangent for pi/2 or -pi/2. So we're going to say y is equal to the inverse tangent of x, where x, again, think of the y values of this function right here. By the way, this is tangent x, not inverse. Where x is any element in the real numbers, but y is between -pi/2 and pi/2. Okay? All right. Great. So now that we know how to kind of take a look for, to evaluate the inverse trig functions for sine, cosine, and tangent, now let's talk about what happens if we compose those together. Ooh, okay. Don't worry, it's not so bad. All right, I'm going to turn these rule lines off. Okay. So let's recall something from before when we talked about inverse functions. If I compose f and its inverse together, I always get x back. So f of f inverse of x is equal to x. And remember, if we compose them the other way, we also get x, right? This is true for inverse functions that are on the domain for which the function exists, right? It's not always true. What do I mean by that? Well, let's take a look at an example. We're going to find inverse tangent of the tangent of -pi/3. Okay? So what the idea here, remember, is that this tangent function is being plugged in to the inverse function. Yeah? All right, so if we were to try to find a value for this, we could work with the innermost function first. So let's look at that. What's the tangent of -pi/3? Well, tangent of -pi/3 is the same thing as sine of -pi/3 over cosine of -pi/3. Yeah. From our unit circle, we know that the sine of -pi/3 is -√3/2, and that cosine of -pi/3 is 1/2. So when we simplify this, we get -√3. Okay, so what we're really doing then is we're finding tangent inverse of -√3. Right? Remember what this means. This means this quantity here represents the angle, the inverse tangent is the angle in the correct interval. So from negative pi over 2 to pi over 2, our restricted interval, not including negative pi over 2 or pi over 2, that has tangent value negative square root of 3, right? Okay, so what angle in negative pi over 2 to pi over 2 has tangent value negative square root of 3? Well, it turns out, right, that the angle that has tangent value negative square root of 3, we just kind of saw that right up here, right? We saw that the angle that has tangent value of negative square root of 3 is right here. It is minus pi over 3, right? And this is okay as an answer because negative pi over 3 is in the interval between negative pi over 2 and pi over 2, all right? So it turns out, so this whole quantity then here is equal to minus pi over 3. Oops. 3. So it turns out that what we were looking for, inverse tangent of negative pi over 3 equals negative pi over 3, right? So this is, we're composing a function with its inverse, and we're getting that x value back. That's what we would expect, right? But, and this is a big but, let's look at another example. If I want to find tangent inverse, again, similar to what we did before, of tangent of 2 pi over 3, right? Turns out that this is not equal to 2 pi over 3. So now we're going to answer the question, why not, right? Okay, let's start with the inner function just like we did before. Where'd it go? There it is. We know that tangent of 2 pi over 3, right? If you work it out, it ends up being negative square root of 3, because 2 pi over 3 is in quadrant 2, where cosine is negative, right? So instead of getting a positive square root of 3 like we did for the earlier, did we do that? No, I'm sorry. We didn't do that. Okay. Turns out that we have negative square root of 3. All right. Now, we'll take that number and do tangent inverse of negative square root of 3, right? Remember, we just did this above, right? What was tangent right here? What is tangent inverse of negative square root of 3? Well, it has to be the angle that's in negative pi over 2 to pi over 2 that has tangent value negative square root of 3. So it turns out that the inverse tangent of negative square root of 3 is going to be minus pi over 3. So our entire thing, tangent inverse of the tangent of 2 pi over 3, does not get us 2 pi over 3, it gives us negative pi over 3, right? And you can use the unit circle, to take a look at that, to see that that's true, right? So why does it not equal that? Well, this number, 2 pi over 3, is not in the range of inverse tangent, right? What's the range of inverse tangent? Negative pi over 2 to pi over 2, right? Yeah, 2 pi over 3 is bigger than pi over 2, all right? All right. What if we compose this function, these two functions, the opposite way? Yeah. All right. Let's, instead of doing, doing the inner tangent and then taking the inverse tangent of it, let's compose the other way. So we're going to find tangent of tangent inverse of negative pi over 3. All right. Okay. So the first thing we have to do is inverse tangent here, right here. Again, that's the angle in the interval, negative pi over 2 to pi over 2, whose tangent value is negative pi over 3. Wait a minute. Wait. You might be thinking the angle, negative pi over 3. That's not what this is, though. We're saying an angle who has negative pi over 3 as a tangent value. Well, that's none of the familiar ones or none of the ones on the unit circle. So how are we going to think about this? Well, negative pi over 3 is approximately equal to negative 1.05. We'll put that on the calculator and find that out. Okay? So we're looking for an angle whose tangent value is negative 1.05. Okay? All right. Let's take a look at the graph of tangent where we have the inverse is defined. Right? So it looks like this. Right? We know that at pi over 4 and at negative pi over 4, we have tangent values. Pi over 4, we have 1 and negative 1 respectively. That's the word, respectively, right? All right. So if tangent of negative pi over 4 is equal to negative 1, right? And we're looking for an angle whose tangent is negative 1.05, right? It's very close to pi over 4, yeah? To negative pi over 4. We're going to say very close to negative pi over 4, right? All right. So now, think about what we're saying, yeah? We're saying, what is the tangent, I mean, if we rewrite our original question, the tangent of the angle whose tangent is, let's back up. The tangent of the angle whose tangent is negative 1.05, right, is going to be very close to tangent of pi over 4. Yeah? Okay, so that's cool. So we know that we're in the interval, right? Because where's negative 1.05? Well, negative 1.05 is just a little bit here, right? So here's our angle. Maybe let's call it alpha. We'll put it right there, okay? Now that angle whose tangent is negative 1.05 is also the angle, wait, hold on. I'm sorry, let's back up. Sorry. So what is the tangent of the angle whose tangent is negative 1.05? Right? Another way to say this is, say this whole phrase as the tangent of the angle whose tangent is negative 1.05 or negative pi over 3, right? So say this very slowly, and you might want to rewind it. We're looking for the tangent of the angle whose tangent is negative pi over 3. Well, what's that angle, right? Well, the tangent of the angle whose tangent is negative pi over 3 has to be negative pi over 3, right? Yeah? And since this angle, negative pi over 3, is in the correct interval for tangent, it can be, oopsie, I don't need the equals to. It can be our answer. And for tangent, you always, if you do tangent of tangent inverse, you always bring you back to your input equals x for all. x. It has to do